Hello. Come on, people. The light is green. Put on the gas. Let's go. Let's go. Hello, Iris. Can you hear me?
Yes.
All right. I'm on Zarzamora. I'm about 5-10 minutes away. So if you could let people know that class is going to start a little late. Later
okay.
than usual. Okay. Yeah. Well, I got away from home way late. It takes me about a half hour to get here, and I left here with 20 minutes to get here. So, yeah. I'm gonna go ahead and leave the room and leave you in charge until I get there.
Okay, no problem.
Okay. Well, I don't know if you drive Zarzamora much, but there's all these bumps.
Oh yeah, it's horrible.
Yeah. I know what the base was when they filled it in. There's a type of clay. It's called Montmorillon clay. It's a swelling clay. And before they knew what they were using, the engineers who filled in would take clay from other places in San Antonio, most notably up around Almas Dam in northern San Antonio, around the Alamo Heights area. They would take, when they were building the dam, they took a lot of that clay out and used it for base, because clay is a good base to use, except for this clay, because it had there's a type of mineral called mica and there was a type of mica that absorbs water, and so the clay would swell. And so they did that on. Let me see. Was it on? I think they did it on 281, and well, there's some other places they did it on 35 and 37 going south, where it used to go up and down and up and down. And that's because they used the swelling clay, and it would swell up, and they had to go in and dredge it all up and put new base in. So I'm pretty sure that's what they did on Zarzamora. Either that or they had pipes collapse and they're just not worried about it. Yeah. Okay, I'm gonna put myself on mute. I hope I can figure out how to do that. Of course, I'm driving, so that's not gonna be helpful. Yeah, I just turned on to campus, so. For those of you who did not hear, I'm late. I'm still in my car. I've just pulled into the parking lot, and I'll be coming into the classroom and set things up in just a minute. So, and someone's in my parking space. It's not really my parking space, but anyway, I'll see y'all in a little bit. I just have to mute my phone. Can y'all hear me?
I can hear you now. I can't
Okay,
see anything. It's just it looks like standby on a blue screen.
yeah, the camera, I haven't turned the camera off. I'm unfortunately horribly late this morning. I wasn't able to get up until about, usually I wake up at 5:30 and I'm up and moving by 6 o'clock. But I wasn't moving until about 6:30, almost 7 o'clock. And if I don't leave by 7:20, I'm gonna be late. And I left at 7:40. So that's what made me late. Was me not kicking myself out of the bed soon enough. Oh, what am I looking for? This here. And I'm going to pin my, when I pin my screen, is my screen pinned on all y'all's screens now? No response, okay. Oh, come on, you stupid thing. In some of the classrooms, these cameras work like a dream, and some of them, they do not. So I push it and turn it on and set it up like I need it to set up. Okay. Let me see, where were we? It tells me we were here. And that's where we shall start, is here. Zoom back up, click that. Sorry about getting here on time, getting here, period. I didn't eat my breakfast. Okay, law of science is what we're going to be talking about. Law of science is quite easy to remember. But law of science works for any triangle. And it's not going to work because I don't have the wire. And so we're going to use it to solve it. They call it solving triangles. What they mean by solving triangles is you find all the measures that are missing. Okay, so I'm talking like I'm talking in a big auditorium. I'm telling you, I got one person in class, so I know. Okay, but can you all hear me? Okay. Y'all need to, okay, thank you. Y'all need to sign in the chat. And if you can't hear me, please let me know by interrupting me. And let me see if this is working now. Okay, can you still hear me?
Yes.
Okay. All right. The SAA means side angle angle. So you know a side, and you know two angles. And that's what both of these are. SAA means here, let me draw a picture of that. So we know this angle
and these two sides. Or we know this angle and these two sides. So we can find the other two, the missing side and the other two angles. We can find their measures. And so that's what they mean by angle, side, side. Oh, no, side, angle, angle. Sorry, side, angle, angle. Yeah. So side, angle, angle. So that's what that looks like. What I was drawing the picture is the next one, which is you have the two sides and the included angle. You can find the other two angles and the third side. Here you know two angles and a non-included side. Included means it's in between. Non-included means it's not in between. So if you had no two angles and a non-included side, side angle, side angle, angle. Then you can find the other two sides and the missing angle. Well, the missing angle is easy to find. That's just, you just add those two and subtract from 180. That's from high school geometry. Actually, I think you should have gotten that from 8th grade mathematics. I taught 8th grade for 2 years. And I can seriously say I've done my time in hell. And then, so if we know these two sides and a non-included angle, we know two sides and a non-included angle. Well, that gets into some issues, but yes, we can find the other two angles and the third side. But please be aware that sometimes, let me work with this one. A and B, although they don't look at, they're supposed to be the same length and angle, that the two angles are supposed to be the same measure. So I have two triangles that could possibly happen from that situation where you have two sides and a non-included angle. And then solve applied problems. Oh, I hate those. I don't like to do those, but I probably will do one or two of them. And I left the damn thing at home. Or I left it in Brazos. It's a shitty eraser. Okay. So that's the kind of deals we're looking at. And this is for any triangle, not just a right triangle. Okay. A lot of the in high school, we pretty much dealt with right triangles in high school geometry. But wrong remote. Yeah, I'm a little frenetic this morning. I know what the problem is. There we go. To solve an oblique triangle. Oblique means that it's not a right triangle. An oblique angle is any angle other than a right angle. So it's not 90 degrees. So that's means, isn't it? That's an E. To solve an oblique triangle, to find the length of the sides and the measures of its angles. To do this, we need to know the length of one side along with two angles, one angle and one other side, or two other sides. There are four possible situations to consider. The length of one side must be known because knowing only the angles results in a family of similar triangles. Like an equilateral triangle, where all three sides are the same length, or it's also known as an equiangular triangle because all three angles are the same measure, they're all 60 degrees. You can have what they mean by a family of similar triangles is I could have an equilateral triangle where each side is 1 inch, or I can have an equilateral triangle where each side is 3 miles. They're similar triangles. That means all the angles are the same measure and corresponding sides are in proportion. That means you can set up a fraction that shows a relationship between all the sides that correspond to each other. The family of right triangles that are the 3, 4, and 5 right triangles, where the 2 legs are 3 and 4, and the hypotenuse is 5. And if you multiply those by the same number, multiply by 2, multiply by 3, 4, 7.9, you'll get another right triangle is just larger because you're multiplying by, or you can multiply by 1/2, 0.1, those kinds of things. So you end up with a family of similar triangles where all the angles are the same and the relationship between the corresponding sides is the same. So that's what they mean there. Now, case 1, where you know one side and 2 angles. Right? This means the side is included between the 2 angles. This means the side is not included between the 2 angles. So these 2 angles, only one of them has this as a side of that angle. And this one, the 2 angles share this side. 2 sides and the angle opposite one of them, also known as side-side angle. That's case 2. And case 3 is where you know 2 sides and the included angle. So these 2 sides form the angle. And then a case where all 3 sides are known. Side, side, side. Okay. So case 1, angle side angle, case 2 of them for case 1, side angle angle, and then side angle, and then side angle side. Yeah, the 2 sides form this angle, and then you have the 3 sides. To solve these triangles is to find the missing side, length of the missing side, and the other 2 measures, the other 2 angle measures. So, or however many, like in this case, the missing two sides, the length of the 2 sides, and the measure of the missing angle, which is easy to do in that case. If you know 2 of the angles, the 3rd one's easy. Now, this is the law of sines. The law of sines I wish they would put a picture with this. This is not a right triangle. Here's angle A, angle B, angle C. It doesn't matter where I put them. What matters is now where I put the A, B, and C. So the A is opposite angle A. The B is opposite the angle B, and the C is opposite the angle C. So however you arrange your triangle or whatever triangle you draw, the side opposite the angle have the same letters, except for the angle, it's a capital letter, and for the side, it's a lowercase letter. Lowercase usually indicates length, where capital letters indicate the angle or the point. Here we have point A, point C, and point B. And so that's what we're talking about there. Okay. The law of sines actually consists of three equalities. Sine of A over A equals sine of B over B. Sine of A over A equals sine of C over C. And sine of B over B equals the sine of C over C. So by the law of the transitive property of equality, I could say that, well, I just know that this equals this. So that's how we get this rule here. So if you know three of these measures, two of them have to be in the angle and one of them has to be in the side, or two of them have to be in the side and one of them in the angle, or all three of them are in the side. I don't know how that's going to work though. Then we use that. It just doesn't matter the order in which you put them. What matters is that the fractions remain the same, and I could switch them around depending upon what I need to find. So, and of course, with all triangles, the measures of all three angles will equal 180 degrees. Now, usually when dealing with triangles, we deal with degrees. Every now and again, it will come across being used radians. And if they do radians, it'll be between 0 and pi. Because 180 degrees is pi. So here we have this situation. Okay. I know two angles, so I add them together and subtract from 180, and that gives me what this angle is. So what is the measure of angle C? So 45 and 55 is what? 100, and 180 minus 100? So this is 80 degrees. So now I have, all right, so since this is side B, so this is B here, and this is side, well, okay, we'll use this as being A, all right, because we have C over there, okay. So the sine of A over A equals the sine of B over B. And I don't need to worry about, well, I do need to worry about C. And the sine of C over C. Well, A is 45, so the sine of 45 divided by, what is A? A is 5, is going to equal the sine of B. B is 55. Got the degree symbol. Over B, we don't know B. And C is 80 degrees, so sine of 80 degrees divided by 5. No, by C, sorry. So I start off by finding, I'm going to use sine of 45. What is the sine of 45? That's pi over 4. On the unit circle, what's the coordinates of that point? Or just type it into the calculator, because you're going to have to do that anyway. So you type it into the calculator, sine of 45. Sine of 45. What is that? Take it down to 4 decimal places. So I hold up 3 fingers. Take it down to 4 decimal places and round it appropriately. That means you need to look at the 5th decimal place to round appropriately. What do you get for it? Sine of 45
radians?
degrees. Unless you want to type in pi over 4 all You-
0.70
.7071.
what?
Okay, so we have 0.7071 divided by 5 equals, and what's the sign of 55? Again, go to 4 decimal places.
0.8192.
0.8192.
Yeah.
Okay. And so, and then this is the only time in mathematics when you cross multiply is when you have 2 fractions that are equal. Well, when you're comparing 2 fractions, you do it then as well, but that's a different situation. So this is going to be 0.7071 equals 5 times times b. I'm sorry, I forgot the b. Right, because I do this multiply, and then I do this multiply. 5 times 0.8192, which equals, what is that? 4 point what?
4.246.
4 point. Multiplying this by 5. What'd you get?
4.246.
I'm not seeing that. I'm not seeing this 2 here.
Oh,
Should that I think that
0.96. I'm sorry. It's 4.096.
0.96. Okay. Multiplying by 5 is the same as dividing by 2 and adjusting the decimal. Because 5 can be thought as actually 1 over 20. As far as, well, no, 10 divided by 2. So you divide by 2, move the decimal 1 place to the right, to the left. I'm sorry. No, to the right. Yeah. Okay. So, and this is what 0.7071b equals. So we're going to divide both sides by 0.7071. Oops. So we get b equals 0.7071 times 4.096. And I don't know many people who can do that multiplying in their head, and I'm not one of them.
I thought you would divide 4.
Divide, yes. Thank you. Get in a hurry. Okay, 4.0. and I'm a little fritz because I was late this morning. 7071. Well, if you round this to to 4 decimal places, what would that be? Oh, okay.
They don't have to.
All right, yeah, and that brings me to a interesting point here. When doing these calculations, I would use as many decimal places as possible. I just said 4 simply for writing up here. Well, what does this equal?
5.79.
5.797?
27.
27. And then round to 2 decimal places. So that's going to be
Like 7.
5.79. Right, because you look at the 2 tells you to stay at 9. If this was a 5 or higher, then we go up to 80.80. And if you're rounding to a certain number of decimal places, and that place is a 0, write it. All right, so now we have this side here, which was what, 5.7927, and that's what I'm going to use in my calculation. For my answer, this would be my answer, but for my calculations, I'm going to keep those 4 decimal places. And so now I do the same thing with C. I know.
You know that.
So we do the 0.7071 divided by 5 equals the sine of 80 divided by 6. So what's the sine of 80 in 4 decimal places?
0.9848.
0.9848.
Yeah, 48.
Okay, thank you. And so again, we do the cross multiply and divide. All right, these are what are known as proportions. When 2 fractions are equal, it's called a proportion. And this is called an extended proportion because it has more than 2 fractions that are equal. And so from here we can do that cross multiply. And so we get 0.7071 B equals 5 times 0.9848, which is 4.924.
24.
And add that 0. This 5 times 8 is 80. So keep that 0. And then we're going to divide this by the 0.7071. And that'll give us what B is.
See.
C is. We already found B. Thank you. I got it stuck in my head. So what does this equal to 4 decimal places?
6.9637.
6.9637, which rounds to approximately 6.96. So we were missing 2 sides and an angle. And so I'm going to, so I round this to that. So this is the number I used in my calculations. Okay. And I round to 2 decimal places. I don't know how many decimal places they're going to round to. They might round to just 1 decimal place. In that case, C would be 7.0 and B would be 5.8. 5.8. So let's verify our work or verify their work. Okay, so the third angle C is used by using formula 2, which is what we did. We added these two angles together and subtracted from 180. Okay, and then using the law of sines twice. And that's usually what we do when solving triangles like this, is we use the law of sines twice. Once to find one side or an angle, and once to find another side or an angle. It just depends upon what we're trying to find. Okay, so they use this, they use the sine of A over A equals B, a sine of B over B. So they're doing it the same way I set it up. And so this, where was the first one? This was the first one. We got the side of B, the length B, and then this was this one where we found the length C. Okay, I'm gonna erase all my work, all my lovely work. And so they went ahead and set them both up at the same time. And then yeah. And then solving this for B means you're gonna multiply by this reciprocal and multiply both sides by B. And yeah. They basically did the same thing I did. You're going to multiply the sine of 55 by 5 and then divide by the sine of 45, which is the calculations I had done. Well, they went to 2 decimal places, so what we got would make them happy, which I don't care about. Okay, questions? And another thing is since I know what this is 0.7071 and divide by 5, and since I know I'm going to use it a second time, I'm just going to what I normally would do, I would divide this out, and then I just multiply, and then I just end up dividing the sine of 55 by whatever number I get here. And I would divide the sine of 80 by whatever number I get here. And that'll give us what C is. And that takes care of the cross multiplying 5. And that's what they did here to get this, is they cross multiplied and divided. So they isolated the B and isolated the C. We know 2 angles and 1 side. So let me see what next. Yeah. So we know 2 of the angles A and B, so finding C is quite simple. That's 180 minus 45, right? What's 180 minus 45? 135. Right, that's one of the 45-degree angles. Knowing your unit circle comes in quite handy sometimes. So now we know 3 angles and 1 side. And so I know the sine of 135 degrees divided by 4 is going to equal the sine of 20 divided by a, lowercase a, And then the sine of 25, where did I get the 4 from? 25 degrees divided by b. Sine of 45, sine of 135 is the same as the sine of 45, right? Because from the unit circle, I know this angle here and this angle here are going to have the same sine, right? Because of the symmetry involved. So I already know the sine of 45 from the previous problem, so that's 0.7071 divided by 4 is going to equal the sine of 20 degrees divided by a, and 0.7071 divided by 4 is going to equal the sine of 25 degrees divided by b. And so those are the two equations I'm going to solve. If I want to solve for a, that means I'm going to multiply by 4. This gives me the equation a equals the sine of 20, 4 times the sine of 20 being divided by 0.7071. Another thing you could do, how you can enter that into the calculator, is you would enter in sine 20. Actually, do 4 times sine 20 divided by sine of 135. And whatever number there gives you would be what letter A is. And doing something similar with this one, that's not an equals, that it goes to this, it becomes this. B equals 4 times the sine of 25 degrees divided by 0.7071. And if you just want to type it into the calculator, it's going to be 4 times the sine of 25. Oh man, it's tiresome. 25, I forgot the degrees. Divided by the sine of 135 degrees, and that's going to give you letter B. So when you get this on an exam, notice I said when. Because all of these calculations are done in the calculator. I need to see you set up the ratios, set up the proportions. Okay. You can set them up this way, or set them individually where the sine of 135 over 4 equals, and the sine of 135 over 4 equals. And then just show me what you type into the calculator. Okay. That's very important that you show me what you're typing into the calculator and the sequence in which you're doing it. Because some people would go ahead and find out what the sine of 20 is and type that out, and then times it by 4, and then write that down, and then find the sine of find the sine of 135, and then just show me how you're getting the numbers. That's all. I know it takes a little extra time to document what you're doing, but that's important. So if there is a mistake made, I want to see where it happened and why it happened. If I can make sense of it, I can
either forgive points or not take off as many points if I can see where the mistake happens and why it happened. I got too cold. And so what'd you get for A? What'd you get for B?
A is 4.9347.
1.9347, and B is,
2.3906.
and this would round to 1.93, and this would round to 2.39. So these are the answers I would be looking for. I expect you to use more decimal places than the answer requires because of rounding. If you just use 2 decimal places all the way through, then you're going to get a different number than what we have here. So if I rounded this to 2 decimal bases, that's 0.71 divided by 4, which is a larger number than this one is. And then whatever the sign of 25, if you round it to 2 decimal places, you're going to get a different number. It's going to be either slightly larger or slightly smaller, but it's going to be a different number. And so you're multiplying it by another number that's different, or dividing it by another number that's slightly different. You're going to get another number that's even more different. Okay, so the error multiplies. So that's why I want you to use more decimal places. 4 decimal places going down far enough. 3, if you use 3 decimal places, then errors do creep into the final answer. But it'll be just by like this would be 0.4, 0.40, or 0.38. So it'd be a hundredths off, maybe 2, but not much. But that's why using 4 decimal places gives you a more accurate answer than using fewer decimal places. If you really want to get picky, use all 8 decimal places that the calculator gives you, or however many they use. That's what I tend to do, but that's me. Okay. Questions on this? A lot of what we've been talking about is not so much how you set it up, but what you do with the numbers as you're finding them. Because I think setting this up, once you understand the formula and how to set the formula up, the rest of this is just arithmetic. Basic algebra. And proportions are easy. You cross multiply and divide. Okay. So we verify. Hopefully y'all wrote down the answers and the work. Place I don't normally put. Okay. So yeah, that was the missing angle we needed. And now the 3 angles and one side are known, so you use the law of sines again. Okay. This is the known number. These are known numbers here. I usually write those first, and then so it's just a symmetric property of equality where it doesn't matter which fraction is on which side of the equal sign. And that's what I did. And so notice theirs is set up slightly different than mine, but then they did the cross multiply and divide. Multiply by 4 over here and multiply by A over here, and then divide by the sign of 135. in both cases. And yeah, they got the same numbers we did. I don't like trying to memorize this formula here. Where A is gonna equal, what side is that? A,
C.
so that was C times the sine of A divided by the sine
Of C.
of C. And where was it? B is the same thing, you're gonna have C times the sine of B divided by the sine of C. I don't see memorizing these formulas. And then if it's a different side and a different angle, then you adjust it appropriately. I just like working straight from these. And then at this point, you just cross multiply and divide. Cross multiply 8 times this and 4 times that. And then you just end up dividing by, in this case, the sine of 135 in both cases. All right, case 2, where you have side angle side, side angle, which applies to triangles for which the two sides and the angle opposite them are referred to as an ambiguous case. Because the known information may result in one triangle, two triangles, or no triangle at all. See here, if A isn't long enough, then it's just swinging in the wind. Okay? And it won't touch this side down here, which comes off angle A. If A is the angle, the length of A is such that you form a right triangle, then you only have one triangle that happens. And it's a right triangle. And the sine of what is the sine of 90? Is 1, right? So 1 over B, yeah. So B times the sine of A. Because dividing by the sine of B is just 1. And for two triangles, well, here we have this situation where A could be either come down here, so we have an obtuse angle, or A comes over here and we have an acute angle. If you remember, obtuse and obtuse angle means its measure is more than 90. And an acute angle, its measure is less than 90. So sometimes you wind up with an acute triangle or an obtuse triangle, an acute and an obtuse triangle, or the two triangles are both obtuse. Obtuse means you have at least one angle that's an obtuse angle. An acute triangle means that all three angles are less than 90. Okay. Then you have three situations that can occur where you either wind up with one triangle or two triangles. All right, if A is smaller than B, so if this side is smaller than the known, than the side adjacent to the angle, then you wind up with two triangles. If A is the longer length, if A is longer, then you wind up with this situation where you just have one triangle. Because if I do this side off of this angle, off of this side, there's only one angle, only one place that'll hit this side. And so you just have one triangle, all right? If A is smaller than B, then you have a situation where the side of length A could possibly hit it in two different locations. And so you create the two different triangles. Where in this case, side C is smaller than in the second case where side C is larger. So it just all depends upon what's going on and what you find. If you have something than this, like this, and I expect to find two sets of solutions. Because you'll have two different angles for angle C up here, two different angles for angle B over here, and two different lengths of side C. So you have to solve for two triangles in one. Won't that be fun? Okay, we'll look at those. So here we have side A is 2, side B is 1, and the angle is 150 degrees. Okay. So now we have this situation. So we're going to find out what this angle is, because we don't know what angle B is, and we don't have any way of finding out what angle B is. But we do have a way of finding angle A. Because we know these three measures. So the sine of A is gonna, if I just multiply both sides by A, I get the sine of A equals A times the sine of C divided by C. Right, A is 2, C is 1. And so this becomes 2 times sine of, what is C, 50 degrees, divided by 1, which is just 2 times the sine of 50 degrees. And that's what the sine of A is. Well, the sine of A equals 2 times the sine of 50 degrees. I don't want to know what the sine of A is. I want to know what A is. So we have something to undo sine. What is that? What's the inverse function for sine? Just had a test on that. The inverse of sine is sine inverse, so if I take the sine inverse of the sine of A, that gives me A. And so if I type it into the calculator, just the way I wrote it here, that'll give me the answer. But what is the sine of 50? So this would be the sine inverse of 2 times whatever the sine of 50 is. What's the sine of 50 degrees?
0.7660.
Okay, so you do 2 times that and then take the sine inverse of it. which is the sine inverse of
1.532.
1.532.
I got it to come back undefined.
Huh?
When I put that in, it came back as undefined.
Uh-oh.
Yeah, it comes up as.
Yeah, because sine is between -1 and +1. So that means this does not form a triangle. Does that make sense? Because if you get something that's undefined, that means it can't happen. That means the situation isn't what you thought it was. So this doesn't form a triangle. Well, I find it interesting that they threw that at us right away. Yeah, so this is what happened. It's left swinging in the wind. It's never gonna hit this side because it's too short. Did I notice that? No, I did not notice the heading. See, it says no solution, so that should have told us that this is gonna happen. I didn't pay attention to the title of the slide. All right, so here we have sine A is 4, sine B is equals 3, and it's a 60-degree angle. Well, the sine of 60 degrees is the square root of 3/2. Okay. So we set up the law of cosines. I mean, the law of sines. There's something called the law of cosines, which is a headache. Okay. So it's a little tricky. That's why I say that. Law of sines is pretty straightforward. I think it's easier, but sometimes you can't use the law of sines. So we have the sine of A equals the sine of A over A equals the sine of B over B. Because I know this angle and its opposite side. I don't know this angle, but I know its opposite side, so I use that one. And once I find this angle, then I can find this angle pretty easily. So we set that up. So the sine of B is going to equal 3 times the sine of 60 over 4, or 3/4 the sine of 60. Okay. So you type that into the calculator, and I would again round to 3 decimal places and then multiply by. This gives us, multiplying both sides by 3, you get 3 sine of 60 degrees over 40, which equals 3/4 times the sine of 60 degrees, which is 0.75 times the sine of 60 degrees. So you could type this into the calculator. 0.75 times sine of 60, which gives you what number?
0.6495.
What?
0.6495.
6495. And since this is a number between -1 and 1, we can use this. So we're going to do the sine inverse. The sine inverse of 0.645695, pardon me. And what's the inverse sine there before?
40.5. You want 4 decimals?
40.5, no, just 2 decimal places. I mean, 1 decimal place is enough. And that's a degree. And so let's see what they did there with theirs. They were 0.65. And they got 4.5, and they also got 139 by subtracting from 180. Because now we have 2 triangles that can be formed, all right? Because I'm gonna back up here a second. A is larger than B, then that means I could have 2 possible angles here. See, because C. How would that work? All right, well. And so then we can find those other 2 sides. Oh, okay. Well, that's what they're gonna look at now. Is this a viable option? Is this a viable option? Because the 60 degrees plus this. The angle is discarded because the sum of the angles in a triangle must equal 180 degrees. And when I add these 2 angles together, I get more than 180 degrees. So that's out of the running. That doesn't even leave enough left over for a right triangle, for a triangle. When I add 60 and 40.5, that gives me 100.5. Which leaves enough room for another angle, which is 7.9, 79.5. And so those are my 3 angles, 60 degrees, 45.5, and 79.5 degrees. And so then I have those law of sines I can use. All right. And they don't show all the calculations here, I hate that. Because we cross multiply, C is gonna equal, all right, I multiply C times that, so that means I'm gonna divide by the sine of 60. So that's this here 4 times. Oh, yeah, okay. Well, I'm not gonna worry about it. I was thinking something else. And so you do those calculations and you get 4.54 for C, and for B, we do the same thing. Oh, we already had B, so yeah, okay. We had 2 of the sides, we needed the 4th side. And we found the 2 angles. If you're trying to find 2 angles, almost always need to check to see can I get 2 triangles out of that one side? And that's if the angle is not included of the 2 known sides. If the known angle is not included between the 2 known sides, then you have a potential for two triangles. Right, and I bet this one is gonna have two triangles, we'll see. So we want to find the third side here. Or actually. We're gonna find one other angle. And they're gonna look for angle B since we know side A, side B. And so we have this situation. And so all I'm gonna do is multiply by 9 over here. And so that's gonna be 9 times the sine of 40 degrees divided by 7 is gonna equal the sine of B. And to find out what B is, I'm gonna need to take the inverse sine of 9 times the sine of 40 being divided by 7. And that's gonna equal angle B. And there's a number of ways to do that. If you choose to find out what this number is first, before you do the inverse sign on it, round 4 decimal places. And then round this to 2 decimal places once you get it. If you want to just type this into the calculator the way it's written, then you do sine inverse, which is second sine, and then 9 times sine of 40 divide by 7. And that's exactly how you would type it in. Well, I don't think you need the times here, do you? No. I can't always remember. I don't, because I don't use the calculator very often anymore. You type it in exactly like that. Show me, write down what you're typing in. And then round that number to 4 decimal places. Or you can find this number right here and show me that you're finding that number. And then you're going to do the sine of that number, sine inverse of that number. And what does this equal?
55.7.
0.73, so it's 55.7 approximately. Because we want to round to 1 decimal place. For in the textbooks, usually for angles, they go to 1 decimal place. And sorry, dude, I'm not gonna have any of you yet today. But you want that Frank. It's talking. People on Zoom can't see me digging around in my bag. Ah, cool one. Because it's not exactly cold. Oh, wow. I was holding the button down, wasn't I? Okay. Well, they got 55 degrees. How'd they get 55 degrees? Or, oh, that's a different problem, isn't it? Well, I went the wrong way. I punched. I was holding this in my hand while I was doing that. So where's that problem? We did, that's the last one we did, No, this is the last one we did. Okay, sorry about this.
That's before you, get the inverse.
Okay, the inverse, okay, okay. So if you found out what was in here first, then this would be 0.83, and I would have you go to 4 decimal places and then do the inverse of that. Which is negative, which is 5.55.7, which is what we got. And then subtracting from 180, you get 124 degrees. Well, if I add 124 degrees to 40, is that less than 180?
Yes.
Yes. So I'm going to get 2 triangles out of this. And that's what it is here. 2 solutions. Okay. So for one set of solutions, I'm going to use B as being 55.7 degrees. And for the second set of solutions, I'm going to use B as being 124.3 degrees. And then the rest of this is just setting those 2. So this is what the 2 triangles will look like. This is the smaller of the 2. Let me get a different color for the larger one. In the larger one. So the angle opposite this side is either going to be this angle down over here, or this angle here. Okay. So the missing, so that's angle C. So C is either going to be this here, or I'll put it inside here for C, for that smaller one, or C is going to be this one. So we have those 2 situations occurring. So those are the 2 angles we're going to use. And so the third angle is either 84 degrees, which is this angle here, or is 15 degrees, 15.7 degrees, almost 16 degrees, and that would be the smaller one. So those are the 2 angles I'm going to use for angle C. So it'll be the sine of 84.3 over C equals the sine of the sine of 40 over 7. That's going to be one side. That's going to be for the in the first situation. In the second situation, the sine of 15.1 divided by C is going to equal the sine of 40 divided by 7. So those are the 2 we're going to be dealing with. And they don't put the numbers in, they just go straight. Oh, they do. Okay. And please notice they're using subscript here to determine which triangle they're dealing with. So subscript 1 is the one in black, the larger of the two, and subscript 2 is the smaller of the two. This one, they're both obtuse triangles. Sometimes you get one obtuse and one acute, but in this case, we're getting two obtuse triangles. Actually not. We're gonna get an acute triangle, which is the first, which is the one in black, and an obtuse triangle, which is the one in blue, because this is 83 degrees, and this is, we found angle B, didn't we? By subtracting 124.3 from 180, and then subtracting 55.7 from 180. And that would give us these two angles here. And then doing the calculating, this side here is 10.84, and this side here is 2.95. And again, that's just doing the cross multiply and divide to get to here. And then you just type the numbers into the calculator to find out what your answer is. At this point here, I would go ahead and put this in the calculator and write those 4 decimal numbers. 0 point something and 0 point something. That way, when I get to here, I don't have to worry about the signs because I already took care of them here. And so then that's just simple numbers to type in. Multiply the numbers in the numerator and divide by the number in the denominator. And so the two solved triangles. All right, when solving these, there's a couple of ways to show me your answers. To show me answers, you can say A equals, B equals, C equals for the sides, and then A equals, B equals, and C equals for the angles. Or you can draw the triangles, putting the numbers in appropriately. Which is what they did here, but I wouldn't superpose them on each other. I would draw them as two separate triangles. Because this, doing it this way could confuse yourself and me. What? Because I think drawing the two separate triangles is a much clearer way of expressing the answer. Because telling me these two different angles here, all right, it may not be as simple as what they showed here, especially when you're writing small, like I tend to do. Okay, next one. Oh, this one. What is this one? To measure the height of a mountain, the surveyor takes two sightings of the peak at a distance of 900 meters apart. Okay. The first observation results in an angle elevation of 47 degrees. Right? So the closer he is, the steeper the angle. So this angle is the 47 degrees. And this angle is the 35 degrees. And I know this distance here is 900 meters. If this is 47 degrees, what is this angle in here? Those two angles are known to be supplementary angles. What do you know about supplementary angles? Two angles are supplementary if what? If you add them, it equals 180. So what's this angle in here? 133. So I have two angles. And I'm going to call this angle A and this angle B. And so what's this angle up here? That's just 47 minus 35. That's an easier number. That's going to be a 12-degree angle here. Because if I add these two together and subtract from 180. Yeah. Because that gives me 68 degrees. And 180 minus 68 is 120 degrees. So now I have the sine of 35 degrees over, oh, I need to assign these letters. So this is going to be angle A, this will be angle B, and this will be angle C. So 35 degrees over A is going to equal the sine of 12 degrees over 900. And that's going to equal the sine of the third angle, which is 133 degrees, divided by B. Because this side over here is B and this side over here is A. So I have my two proportions to work with. So this is going to be A equals 900 times the sine of 35 degrees divided by the sine of 12. And B is going to equal something similar. I'm going to multiply 900 times the sine of 133, sorry, divided by the sine of 12. And that's just calculator work. So what is A? What is B? Someone tell me. Round it to let me see. Let's go to 2 decimal places. So we'll know to the millimeter.
A is 2,482.
2,482.87
.87.
meters.
0.88.
0.88. Okay. And B is approximately how far? It's gonna be a longer distance.
Is that sine 133?
Yeah. Because B, yeah, this is opposite this, and this is 133.
3,165.
3,165.86
.86.
meters. So, but we want to find this length here. Well, again, I can use a lot of signs because I have this, and so this is, what is this? This is 2487, 82, excuse me. 82.88. This is 47 degrees. This is 90 degrees. So what's this angle here? Well, these two angles, the two non-right angle, or the two acute angles in a right triangle are complementary. What it means for them to be complementary, if two angles are complementary, then the sum of their angles is. If all three angles add up to 180 and you take out this angle, what is left? 90. So they have to add up to 90. So that means that's going to be 43.
Yeah.
So this is 43 degrees. So the sine of 47 over h equals, oh, I don't need that angle. This is 90 degrees, right? Equals the sine of 90 over that's h over 200, 2400. I can't fucking write this morning. Okay. 2482.88. And so that means h is going to equal, so that's going to be 248788 times the sine of 47 degrees divided by 1. Because the sine of 90 is 1, right?
Where did it be 2,482?
What did I write? 87. I don't know why I'm wanting to make that 2 a 7, so for some bizarre reason. The joys of having a math teacher who's slightly dyslexic with numbers. I write things different than what I'm saying. Oh man, it used to be really bad. Like I was gonna write, I was gonna write 237, and I wrote down, I think something like 145. We used to be real bad.
Is it times sine 47?
Hmm?
Is it times,
Times the sine of 47. Thank you for keeping me on task.
what is it? 1,815.
1,000.
815.86. And it's 941.
Huh?
It's 941.
Okay, I'm just gonna bounce to what they get for the answer. And then, what would they get? Okay, they rounded to 1 decimal place.
And then they added the height of the person.
They added the height of the person. Because if you recall from the original thing here, all these measurements were done 2 meters from the ground. So they had to add 2 to that, and they rounded. Yeah, this is when I would round it to the nearest decimal. I mean, to the nearest whole number. And so, yeah, okay. I forgot about those Well, they use the larger triangle where we use the smaller triangle. Still get to the same place. So they kept it 2 decimal places here, but then they rounded to one, to the whole number. So when you see, when they tell you the heights of things, sometimes this is how they calculate them, and please be aware that they round. Because you have to round somewhere along the way. Unless you have questions for me, you're free to go. And we won't start with the rescue at sea. We will start with the next section, I believe. And the next section is law of cosines.
When's your next class start?
At 10. And then at 12.
Is your mic still on?
Hmm?
Is your mic still on?
Yes. Let me go ahead and close this. I'm ending the meeting and I'll see y'all on Wednesday.
Wait, sir, I have a question.
Yes.
For retaking the test, do you want me to go in person or are you gonna open a Zoom meeting?
I'll open a Zoom meeting. Can you email me the time it's tomorrow at 10, right?
Yes, 10.
Okay. But go ahead and send me an email reminding me of this.
Okay, I will.
All right, thank you.